In the last lecture, we were discussing the acceleration analysis of a rigid body mechanism. So today we are going to solve probably one or two problems from the exercise, and that is going to be the last topic of the course, which is basically included in the final exam. इसके बाद जो कल की क्लास होगी उसमें हम थोड़ा सा जो टॉपिक्स बाकी बचे हैं काइनेटिक्स रिजिड बॉडी की उसके हवाले से डिस्कशन लाजमी करेंगे, लेकिन ये है कि वो टॉपिक्स हमारे फाइनल एग्जाम में शामिल नहीं होंगे. सो एज पर एज द फाइनल एग्जाम इज कंसर्न, ये आपका आखिरी टॉपिक है जो कि फाइनल एग्जाम में शामिल होगा. प्लस आई होप कि ऑल ऑफ यू रिमेंबर के कल हमारा क्विज नंबर 9 जो कि आखिरी क्विज है वो भी होना है, एंड द लास्ट क्विज इज गोइंग टू बी कंडक्टेड फ्रॉम द टॉपिक ऑफ velocity analysis of a rigid body mechanism using the relative velocity method. आई होप कि सबको ये टॉपिक क्लियर है relative velocity method वाला.
ये सर टॉपिक क्लियर है सर. क्विज फ्राइडे को हो सकता है, कल हमारा लैब फाइनल भी है.
क्विज फ्राइडे को किस टाइम पे?
तो फ्राइडे को किसी भी टाइम पे, फ्राइडे पूरा फ्री है हमारा.
अब्दुल्ला प्लीज यार, नहीं सर कल जल्दी क्लास ले लेना, हो जाएगा कल ही ले लें.
चलें, ये मैं ऐसा करता हूँ सीआर के ऊपर छोड़ देता हूँ, लेकिन फिर मुझे ये ना होना कि एक्चुअली जब भी हम कोई शिफ्ट करते हैं ना तो ये ना हो किसी एक आध बंदे का भी मिस और हो गया, मुझे तो पता ही नहीं चल सका था.
नहीं सर, अभी तो 5 दिन पड़े तो अभी अनाउंस कर देंगे सारा. देखें,
वो मैं सीआर पे छोड़ता हूँ कि आपने फ्राइडे को किस टाइम पे रखना है वो आप मुझे बता दें. ठीक है, तो फिर वो क्लास भी और क्विज भी दोनों चीजें फिर फ्राइडे को ही होंगी, क्योंकि फिर कल क्लास नहीं करेंगे, क्योंकि वो क्लास तो 15 मिनट की क्लास है छोटी सी, जिसमें इंट्रोडक्शन होगा आखिरी टॉपिक्स का जो रह गए जी. तो फ्राइडे को आप मुझे आधा घंटा बता दें जिसमें पहले 15 मिनट में क्लास हो जाएगी और बाकी 15 से 20 मिनट में क्विज हो जाएगा.
ठीक है सर.
ठीक है, ओके. सो फिर ये डन है कि कल क्लास नहीं होगी और ये क्लास अलॉन्ग विद क्विज जो है वो फ्राइडे को होगा, और टाइम आप एग्जैक्टली मुझे क्लास से पूछ के बता दीजिएगा.
ठीक है सर.
ओके, सो एक्सेलरेशन एनालिसिस की बात करते हैं इंशाल्लाह. आज हम एक्सेलरेशन एनालिसिस का टॉपिक कंप्लीट करेंगे. सो प्रोबेबली वी आर गोइंग टू सॉल्व 2 एग्जांपल्स relevant to this acceleration analysis, and since in both those examples the angular velocities are unknown to us, so probably first of all we need to perform the velocity analysis. तो एक तरह से आपकी क्विज की रिवीजन भी हो जाएगी जब हम velocity analysis जो है वो परफॉर्म कर रहे होंगे. So starting with the first problem, which is problem 16-120, in which we have a rigid body mechanism being shown to us, and we need to find out if the piston is moving towards the right with the velocity and acceleration shown to you, that is, it is moving towards the right with a speed of 5 feet per second and an acceleration of 3 feet per second square. We need to determine the acceleration of point A, the linear acceleration of point A, which is constrained to move within the curve path having a radius of 1.5 feet. So in order to perform the acceleration analysis, or in order to determine the acceleration of point A, first of all, since omega is not known to us, so we need to first of all find out this omega, that is omega of this rod AB. In order to perform the velocity analysis first, can you tell me what should be the value of VB vector? We are using the conventional XY coordinate system. Since the piston is moving towards the right, so point B or piston B would be moving with a speed of 5 feet per second. That is, the vector form of VB is going to be 5I. What about the motion of link AB? Is it rotation or general plane motion?
General plane motion.
So it is general plane motion. Probably अगर हम इस motion को गौर से देखें तो at the very next instant point A would be located at this point, जो कि मैंने black color से cross बनाया है. Similarly, point B would be located at this point. So if I draw this link AB at the very next instant, it would be in probably this location. So it has undergone simultaneous translation as well as rotation. It means that this link AB would be in general plane motion. So applying the general plane equation on this link AB, taking point B as our base point, the equation would become VA to be equal to VB plus omega cross R, where omega is going to be the angular velocity of this link AB and R is going to be the relative position of A with respect to B. So this is the relative velocity equation. In this equation, VB, as we have written in step number 1, it is going to be 5I plus omega cross R. If we take a look at these instants, this rigid link is basically rotating in this direction, which is counterclockwise direction. So we can write omega to be equal to omega ABK cross RAB, the relative position of A with respect to B. So basically we are talking about the vector which is starting from point B towards point A. So since this vector lies in the second quadrant, so it should have negative x and positive y. The total magnitude of this vector is 2 units and the angle is given to you as 30 degrees. So we can write it as minus 2 cos of 30i plus 2 sine 30j. So this is going to be the vector form of RAB. Okay, so once you take this cross product, it would become 5i plus omega ABK cross minus 1.732 I plus j. So this is going to be this vector. Again, after taking this cross product, it is 5i. If we are using that smaller circle ijk, so we can write minus 1.732 omega AB and k cross I is j. So this first term would be j. Similarly, the second term would be omega AB and k cross j is minus I. So we are going to put it as minus I. So let us say that this is our equation number 1. I hope that this cross product is clear to all of you. Okay, what about the left hand side of this equation? It represents the absolute velocity of point A. Now, since point A is constrained to move within a circular slot having a radius of 1.5 foot, so whenever a particle or a rigid body is moving in a circular path, what should be the direction of velocity? Tangent to the circle. So for this instant, what is the line which is tangent to the circle at this instant? The vertical axis. Okay, so if the piston is moving towards the right, what should be the velocity of point A? Down the y-axis or upward? Down the y-axis. So can we write VA to be equal to minus VAJ?
Yes.
Okay, so putting the value of VA vector to be equal to minus VAJ and then comparing the I and J coefficients on both sides of this equation. So once we compare the I coefficients, we are going to get 0 equal to 5 minus omega AB. Once we compare the J coefficients, we are going to get minus VA to be equal to minus 1.732 omega AB. So solving these two equations would give us the value of omega to be equal to 5 radians per second. And since this value comes out to be a positive quantity, it means that our assumed direction of omega is correct. Similarly, the value of VB comes out to be 8.66 feet per second. And again, since it comes out to be a positive quantity, it means that our assumed direction of VA is correct, that is downward. I hope that this velocity analysis is clear to all of you. एक तरह से revision है आपके quiz number 9 की. Okay, now moving on to the acceleration analysis. In order to perform the acceleration analysis, it is given to us that this piston A is moving towards the right with an acceleration of 3 feet per second square. So again, starting from that piston, the acceleration of point B is given to us as 3I feet per second square. And since link AB is in general plane motion, so we are going to write the relative velocity equation for this link AB, taking B as our base point. So that equation would become AA, which is the absolute acceleration of A, should be equal to AB, which is the absolute acceleration of B, plus alpha cross R minus omega square R, where alpha is going to be the angular acceleration of this link AB, omega is going to be the angular velocity of this link AB, and R is going to be the relative position of A with respect to B. So these are the vectors जो कि हमने लिखने होंगे. As we know that AB is basically equal to 3I plus alpha cross R. Again, alpha is assumed to be in a counterclockwise direction, so we can write this alpha as alpha ABK cross RAB. RAB हमने already निकाला है पिछले step में, which is minus 1.732 I plus j. So this was our RAB minus omega square. Omega अभी again हमने last step में निकाल लिया था, which was 5. So 5 square into minus 1.732 I plus j. So this is going to be our right hand side of this equation. Again, we are going to use the smaller triangle method, smaller circle method for finding the cross product. So once we solve or once we evaluate this cross product, the right hand side of this equation would be of the form, अगर मैं उसको simplify करके लिख दूं, it should come out to be 46.3 minus alpha AB I minus 1.732 alpha AB plus 25 J. So this is going to be the right hand side, whereas the left hand side represents the absolute acceleration of point A. So let us say that this is our equation number 1. Okay, now as far as the acceleration of point A is concerned, since point A is constrained to move in a circular path, so the acceleration of point A would comprise of two components. The first one is the tangential component of acceleration, which is AAT. The second one is the normal component of acceleration, which is AAN, and the total acceleration is going to be the vector sum of tangential and normal components. I hope के ये चीज याद है आपको chapter number 12 की.
Yes.
Okay, so what about the normal component of acceleration? What should be its magnitude? अगर मैं AAN की बात करूं, the normal component would have a magnitude of, बता सकते हैं?
सेंटीमीटर टाइप जो निकाल
जी, तो क्या था वो? कुछ चैप्टर 12 को रिवाइज करें, रिफ्रेश करें.
स्क्वायर ओवर आर.
So the normal component would have a magnitude of v square over rho या v square over r. What about v? कौन सा v होगा ये?
ये वो वाली
सर tangential velocity होगा,
जो ऑलरेडी हमने स्टेप नंबर 1 में फाइंड आउट किए, विच इज द वेलोसिटी va. दैट वेलोसिटी वाज, इफ यू रिमेंबर, अभी हमने पिछला स्टेप किया था, दैट वाज 8.66 feet per second. So basically this va was 8.66 feet per second. What about rho? ये रेडियस क्या है जिसपे a जो है वो मूव कर रहे हैं?
2 feet.
जरा गौर से देखें
सर. 1.5 feet.
चलें, मैं आपसे एक और कहता हूँ, अभी हम सवाल को तो कंटिन्यू रखेंगे ही. व्हाट अबाउट कि मैं ये जो कार्डबोर्ड जिसमें स्लॉट बना हुआ है इसको रिमूव कर दूं और इस कार्डबोर्ड को मैं रिप्लेस कर दूं एक रिजिड लिंक से जो कि पॉइंट डी कह लें, इससे ग्राउंड हुआ है. कार्डबोर्ड हटा दूं और उसको इस लिंक से जो है वो रिप्लेस कर दूं. अभी भी रोटेशन ऐसी होगी पॉइंट ए की.
यस सर.
ठीक है, तो इट मीन्स के आपके पास जो पॉइंट ए है वो एक तरह से रोटेट कर रहा है इन अ सर्कल हैविंग अ रेडियस ऑफ 1.5 फुट. अब यहाँ अक्सर स्टूडेंट गड़बड़ क्या करते हैं कि इस 2 फीट से इसको कंफ्यूज करते हैं. नहीं, 2 फीट तो लिंक ए भी जनरल प्लेन मोशन करे, लेकिन पॉइंट ए जो है इट इज इन प्योर रोटेशन with respect to point D, which is at a distance of 1.5 meters from point A. In other words, अगर मैं इस कार्डबोर्ड की जगह ये एक रेड कलर का रिजिड लिंक लगा दूं हैविंग अ लेंथ ऑफ 1.5 फीट, तो वो लिंक जो है वो प्योर रोटेशन में है अबाउट पॉइंट D. Is this point clear to all of you? It means that in this AN, V तो हमारे पास आ गया which is 8.66. जो रॉ की वैल्यू होगी that should be equal to 1.5 feet. Is this point clear to all of you? Okay, the magnitude of AN is V square over rho. What about its direction? As per our understanding, normal component किस तरफ होता है?
towards the center.
परपेंडिकुलर
towards the center होता है. So towards the center आपकी कौन सी एक्सिस बन रही है यहाँ? एक्सिस कौन सी है towards the center of that circle?
AB.
नहीं. Any other correct answer?
हॉरिजॉन्टल एक्सिस.
हॉरिजॉन्टल एक्सिस. तो आप यूनिट वेक्टर i के साथ इसको रिप्लेस कर सकते हैं. सो द ओवरऑल AN वेक्टर वुड बिकम v square over rho I. Is this point clear to all of you?
Yes.
So this would comes out to be 50i because v square over rho is 50. So AN would be equal to 50i. Similarly, if we talk about the tangential component of acceleration, which is AAT although you don't know its magnitude, उसका magnitude unknown है, आप उसको AAT के तौर पे ही रखेंगे. But what about the direction of tangential component of acceleration? किस direction में होता है AAT?
वर्टिकल होगा उनके टेंजेंट टू सर्कल है.
As the name indicates, since it represents the tangential component, so it should be basically tangent to that circle, tangent to that curve at that instant. So at that instant, tangent to the curve is your vertical axis. So what should be AAT vector? It should be minus AATJ, isn't it?
Yes, sir.
So overall, this vector AA would become 50I minus AATJ. Clear है ये चीज?
यस.
So replacing this AA as 50I minus AATJ and then comparing the I and J coefficients on both sides of this equation number 1. If you compare the I coefficients, it means that 50 should be equal to 46.3 minus alpha AB. Once you compare the J coefficients, it means that minus AAT should be equal to minus 1.732 alpha plus 25. So once you solve it, alpha AB comes out to be minus 3.70 radians per second square. The negative sign indicates that the assumed direction of alpha is going to be reversed. That is, alpha is acting in a clockwise direction. Solving for the other unknown, which is AAT, will give you the value of AAT to be equal to 18.59 feet per second square. And since it comes out to be a positive quantity, it means that the direction of tangential component is basically in line with the direction of velocity. Is this point clear to all of you?
Yes.
So once you have found AN and AT, then the overall acceleration would have a magnitude of AT square plus AN square whole under root, which comes out to be 53.34 feet per second square. Clear है? कोई क्यूरी वेलोसिटी एक्सेलरेशन के हवाले से जो आप पूछना चाहें?
सर ये ओमेगा स्क्वायर आर है, इसमें ओमेगा स्केलर है, सिर्फ मैग्नीट्यूड पुट करेंगे?
जी, सिर्फ ओमेगा का मैग्नीट्यूड पुट करना है. ये जो हमारे पास ये फॉर्म है अल्फा क्रॉस आर माइनस ओमेगा स्क्वायर आर, इसमें बाकी सब चीजें वेक्टर हैं, सिर्फ ये जो ओमेगा है इट इज स्केलर मैग्नीट्यूड ऑफ ओमेगा. अगर आप चाहें ओमेगा को भी वेक्टर फॉर्म में पुट करना चाहते हैं तो देन यू आर गोइंग टू यूज द फॉर्मूला अल्फा क्रॉस आर प्लस ओमेगा क्रॉस आर. अब इस सूरत में अगर आप ओमेगा डालना चाहते हैं तो वो वेक्टर फॉर्म में डालेंगे, डबल क्रॉस प्रोडक्ट ले लेंगे, लेकिन इन द एंड ये नतीजा आपका यही निकलेगा जो माइनस ओमेगा स्क्वायर आर के बराबर है. तो वहां अपना टाइम जाया करने के बजाय डायरेक्टली यू कैन यूज द स्केलर वैल्यू ऑफ ओमेगा.
इसमें सर साइन को देखेंगे कि नहीं, अगर प्रीवियस वैल्यू इसकी नेगेटिव में हो तो नेगेटिव पुट करेंगे.
कौन से साइन को? देखिए स्केलर वैल्यू है, ये सिर्फ स्केलर मैग्नीट्यूड है, स्क्वायर है ओमेगा स्क्वायर, तो साइन से कोई फर्क नहीं पड़ेगा. Okay, any other thing which you want to ask regarding problem 16-120? Okay, so moving on to the final problem of this course, which is problem 16-121, and you can expect a problem of this sort in your final exams as well. Okay, again you have a rigid body mechanism in which we have a link AB, the crank, which is rotating with an angular velocity of 6 radians per second and an angular acceleration of 2 radians per second square, both directed in a clockwise direction. So this crank AB is rotating in a clockwise direction with this much of kinematics. You are asked to determine the acceleration of point C, which is constrained to move within the curve path shown to you, having a radius of 150 millimeter. You also need to find out the angular acceleration of this connecting rod. Since omegas are not given to you, so first of all, again, आपकी एक तरह से revision हो जाएगी. We need to perform the velocity analysis, and then we are going to determine omega BC from that analysis, and then we are going to use that omega in order to perform the acceleration analysis. So velocity analysis हमने शुरू करनी है. किस लिंक से हम उसको स्टार्ट करेंगे?
लिंक AB.
Link AB से start करेंगे. So in order to find out the velocity of point B, since link AB is in pure rotational motion with respect to point A, so VB should be equal to omega cross R, where omega is the angular velocity of this link AB and R is basically the absolute position vector RB. Now, since this link is already given to us rotating in a clockwise direction, so we are going to put its correct value, which is minus 6k because of that clockwise rotation. अब आपने assume नहीं करना, जो चीज आपको given है उसको आपने उसी form में लेना है. So it is going to be minus 6k cross RB. So what is this vector RB?
Vertical 300 millimeters.
So vertical है 300 millimeter, positive, negative?
The positive, upward.
Upward. So it is going to be 0.3 J. So once you take this cross product, what is K cross J?
Negative I.
Negative I, so negative negative positive हो जाएंगे, and it would comes out to be 1.8 I. So B is going to be 1.8 I. Okay, moving on to the next link. Which is the next link at which we are going to move?
BC.
Sir, ये link BC.
It is the connecting rod which is link BC. So what should be our base point?
B.
Link B. Sorry, point B.
B. So we are going to write the relative velocity equation, which is VC equal to VB plus omega cross R. Now omega is going to be omega BC, which is the angular velocity of this link, and R is going to be the relative position of C with respect to B. Okay, if we take a closer look at the motion of this link, since point B is in pure rotation with respect to point A, so at the very next instant, probably link B is going to be a little downward. जो कि circle cross कर चुका है, it is going to be a little downward. Similarly, link C is going to be at this point. So probably the next position of this link is shown to you as this red line. So what do you think the direction of rotation of link BC, angular velocity इसकी clockwise है या counter clockwise है?
Sir, clockwise है. Counter clockwise.
दोबारा और कर.
Counter clockwise, sir.
Okay, थोड़ा सा इस डायरेक्शन और से देखें.
Sir, clockwise.
क्लॉकवाइज है.
क्लॉकवाइज है.
Yes.
No, sir.
चलें
Counter
एक काम
clockwise.
नहीं है ये क्लॉकवाइज ही, लेकिन एक काम करते हैं, लेट अस अज्यूम इट इन अ काउंटर क्लॉकवाइज डायरेक्शन. ऑल्दो मुझे नजर आ रहा है कि क्लॉकवाइज है, लेकिन लेट अस अज्यूम इट इन अ काउंटर क्लॉकवाइज डायरेक्शन एंड लेट अस सॉल्व इट. इफ इट साइन कम्स आउट टू बी पॉजिटिव, अजम्पशन करेक्ट हो जाएगी. साइन नेगेटिव आ गया तो मैं अपनी अजम्पशन को रिवर्स कर लूंगा. इज दिस पॉइंट क्लियर टू ऑल ऑफ यू? ऑल्दो मुझे नजर आ रहा है क्लॉकवाइज है, लेकिन चलें जस्ट समझने के लिए मैं इसको काउंटर क्लॉकवाइज अज्यूम कर लेता हूँ. ठीक है.
Okay, sir.
What about this vector RCB, the relative position of C with respect to B? कौन सा quadrant है?
Second quadrant.
It is second quadrant, so positive x, negative y, angle is 30 degree, so 0.5 cos 30i minus 0.5 sin 30j, वो आपका vector हो जाएगा.
उल्टा नहीं होता. ये x
Fourth
axis negative, y axis positive.
Fourth quadrant में
sir.
positive x, negative y.
Yes, sir.
वाई.
Fourth quadrant. Right.
So 0.433i minus 0.25 j, ये आपके पास पोजीशन वेक्टर r आ जाएगा, relative position vector. ठीक है.
Yes.
Okay, so once you take this cross product, the right hand side would become 1.8i. The first term is 0.433 omega bc, k cross I is j, so the first term would be equal to j. The second term would be minus, sign मौजूद है, 0.25 omega bc and k cross j is minus I, so ये minus minus plus हो गया और आपके पास राइट साइड पे ये चीज आ जाएगी. ठीक है, क्रॉस प्रोडक्ट कर लेंगे आप इस तरह.
Yes, sir.
Okay, coming towards the left hand side, what does that left hand side indicate?
Velocity of C.
Velocity of C, since point C is constrained to move within a circular path, so the velocity in case of circular motion is tangent to the curve. So what should be the direction of velocity in this case?
VC equal VCJ.
So VC should be equal to minus VCJ. So putting the value of VC to be equal to minus VCJ and then comparing the I and J coefficients on both sides of this equation. So once you compare the I coefficients आपके पास 0 to be equal to 1.8 plus 0.25 omega BC आ जाएगा. From here you can see clearly that the value of omega comes out to be negative quantity. That negative quantity says that our assumption regarding omega, which was counterclockwise direction, was incorrect. Rather, this omega is rotating in a clockwise direction. ठीक है? Clear है ये चीज?
माइनस जे क्यों लिया है सर वीसी के साथ?
देखें, आपके पास ये इस तरफ लिंक जा रहे हैं ए बी ना क्लॉकवाइज डायरेक्शन. सो एट द नेक्स्ट इंस्टेंट, जिस तरह मैंने कहा था, अगर हम नेक्स्ट इंस्टेंट बनाने की कोशिश करें, ये सर्कल में मूव कर रहा होगा ना पॉइंट बी, तो इसका मतलब है अगले इंस्टेंट पे ये थोड़ा सा नीचे आ चुका होगा पॉइंट बी.
यस सर.
अकॉर्डिंगली पॉइंट सी रिजिड बॉडी है, डिफॉर्म तो हो नहीं सकती. पॉइंट सी जो है वो इस तरफ मूव कर गया होगा, तो एक तरह से पॉइंट सी जो है वो डाउनवर्ड मोशन कर रहे हैं, इसलिए हमने उसको माइनस वी सी जे लिख लिया था.
सर इसको जूम कर सकते हैं?
देखिए, डबल अजम्पशन ना करें, कोई एक चीज आप अज्यूम कर सकते हैं.
और सर ये बी पे पिन ज्वाइंट नहीं लगा था?
बिल्कुल पिन ज्वाइंट है.
तो फिर सर तो सी तो मतलब अगर पिन ज्वाइंट है तो सी तो ऊपर मोशन फिर कर रहा है.
ऊपर कैसे कर रहे हैं? देखिए, ये आपका सर्कल है जो कि पॉइंट बी बना रहे हैं. येलो से नजर आ रहा है वो सर्कल?
यस सर.
अब देखें, ये लिंक किस डायरेक्शन में जा रहा है? क्लॉकवाइज डायरेक्शन में ए बी जो है. तो अगले इंस्टेंट पे पॉइंट बी कहाँ होगा? इस जगह नहीं होगा.
जी बिल्कुल.
तो इस जगह अगर होगा तो रिजिड बॉडी मेंटेन रखने के लिए पॉइंट सी को हर हाल में नीचे की तरफ आना है. ठीक है, पॉइंट सी ऊपर जा सकते हैं वैसे
अगर काउंटर क्लॉक मोशन हुआ ए बी की.
नहीं, अगर हुआ, लेकिन क्लॉकवाइज ए बी कर रहे हैं, तो क्लॉकवाइज ए बी करने के नतीजे में वो रिजिड बॉडी डिफॉर्म होगी तो पॉइंट सी ऊपर जाएगा, अदरवाइज पॉइंट सी ने नीचे जाना है. और रिजिड बॉडी चूंकि डिफॉर्म नहीं हो सकती, लिहाजा सी पॉइंट ने नीचे की तरफ मूव करना है, इसलिए हमने उसको वी सी जे के बजाय माइनस वी सी जे लिखा है. ओके, सो द साइन ऑफ वी सी कम्स आउट टू बी पॉजिटिव. इस पॉजिटिव साइन का क्या मतलब है?
सर करेक्ट
Assumption
है.
कि हमारी assumption regarding point C correct है, and point C is basically traveling downward. So VC आपके पास downward motion कर रहे हैं. Okay, so once you have completed this velocity analysis, let us now move on to the acceleration analysis, because we were asked to determine the acceleration of point C as well as the angular acceleration of this connecting rod. So in order to start this acceleration, we are again going to start from point B, but since point B is doing circular motion with respect to point A, so what should be the acceleration vector AB with reference to link AB? Point B is in pure rotation with respect to point A. So acceleration क्या होगा? Alpha cross R minus omega square R, where alpha is going to be the angular acceleration of AB, omega is going to be the angular velocity of AB, and R is basically the absolute position vector, that is vector position of point B with respect to fixed point A. So alpha cross R minus omega square R, again alpha is given to you as 2 radians per second in a clockwise direction, so you are going to write it as minus 2k cross 0.3 I. इसी तरह minus omega AB, which is 6 square and 0.3 I. So this would become 0.6 I minus 10.8 J meter per second square. So this is going to be the absolute acceleration of point B. Clear है यहाँ तक? Okay, the next link to which we are going to move is the connecting rod. So we are going to make point B as our base point. The equation would become acceleration of C to be equal to acceleration of B plus alpha cross R minus omega square R, where alpha is now the angular acceleration of link BC, omega is going to be angular acceleration of link BC, and R is going to be the relative position vector, relative position of C with respect to B. AB आपने इससे पिछले स्टेप में ऑलरेडी डिटरमिन किया है, which is 0.6 I minus 10.8 J plus alpha, again alpha आप assume करेंगे in a counterclockwise direction cross R. R आप ऑलरेडी फाइंड कर चुके हैं इससे पिछले उस केस में, which is 0.433 माइनस 0.25 जे, ये आपके पास आई था, माइनस ओमेगा, ओमेगा आपके पास आ गया था 7.2, सो 7.2 स्क्वायर मल्टीप्लाई बाय दिस आर, ये आपके पास ओमेगा स्क्वायर आर हो जाएगा. सो वंस यू टेक दिस क्रॉस प्रोडक्ट, आपके पास राइट साइड कंप्लीट हो जाएगी. कमिंग टुवर्ड्स द लेफ्ट हैंड साइड ऑफ दिस इक्वेशन, the left hand side of this equation represents the absolute acceleration of point C. Since point C is in pure rotational motion, so this AC vector would comprise of two components. The first one is the tangential component of acceleration. The second one is the normal component of acceleration, and the total acceleration AC would be equal to the vector sum of its two components. Okay, coming towards this normal component, ACN, मैग्नीट्यूड क्या होगा इस ACN का? V स्क्वायर बाय R, और V हम ऑलरेडी इससे पिछले स्टेप में फाइंड कर चुके हैं that V was basically 3.118, so it is going to be 3.118 square over R. What is R here? So it is going to be 0.15 meter. So V square, which is 3.118 square divided by 0.15, ये उसका मैग्नीट्यूड हो जाएगा. अगर हम इसके डायरेक्शन की बात करें, तो in which direction this normal component would be acting?
Sir, towards the positive x-axis.
So towards the center, which is towards the positive x-axis. So we can write this vector as V square over rho I. Is it clear to all of you?
Yes, sir.
Okay, coming towards the second component, which is ACT. Although we don't know the magnitude of this tangential component, but as far as our understanding is concerned, tangential component किस direction में act करता है?
Tangent to the curve.
Tangent to the curve. So tangent to the curve आपकी कौन सी एक्सिस बनती हैं?
Y-axis.
Y axis. So we can write it as minus ACT J. So overall, the vector AC would be equal to V square over rho I minus ACT J. Clear है ये चीज?
Yes, sir.
Okay, so now comparing the I and J coefficients on both sides of this equation. So once you compare the I coefficient, आपके पास जो equation आएगी वो ये वाली equation होगी. Once you compare the J coefficients, you are going to get this equation. So solving these two equations would give you the value of alpha, which is the angular acceleration of this connecting rod, to be equal to 346.6 radians per second square. And since this value comes out to be a positive quantity, it means that your assumed direction of alpha is correct. Finding the value of ACT, this ACT comes out to be a negative quantity. What does that mean?
Deceleration.
It means that the tangential component of acceleration is acting upward, isn't it?
No, sir. Decreasing acceleration, sir.
देखें, आपके पास velocity जो है वो इसकी आई थी डाउनवर्ड डायरेक्शन में, जो हमने पहले स्टेप में फॉलो की थी. The tangential component of acceleration is opposite to the direction of velocity. What does that mean as far as the curvilinear motion is concerned?
Retardation.
Velocity के magnitude में क्या हो रहा है?
Decrease.
Decrease आ रही है. So that's why आपके पास tangential component जो है that is opposite to the direction of velocity आया है. Is this point clear to all of you?
Yes, sir.
Because the tangential component of acceleration किसको represent करता है? अगर हम chapter 12 की understanding पे जाएं, the tangential component of acceleration basically represents the rate of increase or decrease in the magnitude of velocity. So if the velocity's magnitude is increasing, then ACT and V are going to be in the same direction. However, if the direction of tangential component is opposite to the direction of velocity, then it means that the particle is the magnitude of velocity is decreasing. ठीक है, ये समझ आ गई ये बात हर एक को? Okay, so with this, our course जो कि such final exam में आने हैं, that is being completed.